Greetings, Patriots. Please make sure you've set up your notebook and are ready to go with your guided notes for Lesson 8. In this lesson, or Lesson 7, I should say, in this lesson, we are looking at finding the constant rate of change, once again, and the constant of proportionality from a graph or a table. And we're going to identify whether that relationship is proportional or not proportional. So let's go ahead and look at this first set of tables, okay? So in this, we, again, always want to label, right, our x and our y variables. So here we're looking at the number of packages and their total cost. So again, how do I find the constant rate of change? Well, I go ahead and do change in y, right as it says there, 11 minus 20 over change in x, 1 minus 2. When you type that into your Desmos calculator, you're going to get negative 9 over negative 1, which equates to just 9. Go and check the next set of points. So once again, I can go and find the change in y over change in x. And when I do that, I get the same thing, negative 9 over a negative 1, and that is a positive rate of change of 9. I can continue and find the rate of change here, and when I do that, I'm going to get 29 minus 38. If I subtract that, that gives me a negative 9 over 3 minus 4, and that's going to be negative 1, which gives me a constant rate of change. So I'm just checking, do I have a constant rate of change here? And I do. So this is a nice indicator that I am multiplying in order for me to get my total cost, right? I have to be multiplying that constant rate of change, right, of 9 times the number of packages that I'm dealing with. Okay, so interesting. I'm going to hold that thought real quick. So let's go see if this table is proportional. So how do I check proportionality? Well, I need to take my y coordinate, right? Here it is. So here's 11. For my first ordered pair, I have 1 comma 11. One package costs $11. So I'm going to literally take 11 divided by 1, and that's going to give me an 11. So I need to check if my ratios are equal or not. Okay, now I'm going to go do the same thing for the next ordered pair. And the next ordered pair is 2 packages are costing $20. So I'm going to take 20 and divide it by 2. And when I do that, I get 10. Well, 20, well, already, I'm not even going to continue. This tells me that my ratios are not equal. So therefore, I know that I'm dealing with a non-proportional situation. So I'm curious, though, if my constant rate of change, here's my number of packages, 9 times 1, but my cost was 11, there must be an additional cost going on here. 9 times 2 is 18, but there must be an additional cost going on here, okay? So, looks like it's plus 2 almost. 9 times 1 is 9, 10, 11, yep, plus 2. So there's an additional fee of some sort. 9 times 2 is 18, and 18 plus 2 is 20. So it looks like my equation here is 9 times the number of packages plus $2. I can do that again by checking 9 times 4, which is, I know, 36. If I add 2 to that, it gives me 38. So it seems like that's my equation for this situation. So once again, here I have a constant rate of change of 9, but I have no constant of proportionality. So because these two are not equivalent and my ratios were not equal to each other, this lets me know I'm dealing with a non-proportional situation. Second table and compare. Now I'm looking at t-shirts and the cost. So what I'm going to do is I'm going to go see if there's a constant rate of change, right? I want to go ahead and subtract my cost and my t-shirt, see how much I'm paying per t-shirt. So I'm going to go ahead and do 34 minus 17 over 4 minus 2, okay? And so when I do that, when I actually subtract each one of those, that gives me 17 divided by 2. And 17 divided by 2 is $8.50. Let's go ahead and do the next one. So if I take $59.50 minus 34, so 59.5, oops, sorry. Of course, go use your Desmos calculator, minus 34. That gives you $25.50. And if I take away 7 minus 4, that gives me 3. So divided by 3, that also is giving me a rate of $8.50. So $8.50 is my constant rate of change. Well, let me see if that works. If I take 2 times 850, does that give me 17? Let me check. Yes, it does. 4 times 8.5 is, ooh, what do you know? $34. That means that 7 times 8.5 is also going to be $59.50. And you can check and see if that's your constant rate of change. So it looks like that's what I might be paying per shirt. So now let's go ahead and check every ordered pair. So I'm going to take the first ordered pair to see if my ratios are equal to each other. So 17 divided by 2 is equal to 850. Let me take my next ordered pair of 434. Well, when I take in my calculator and I take 34 and divide it by 4, I also get 850. So it seems like my ratios are working. If you take $59.50 and divide that by 7, you also get 850. So my ratios of y divided by x are equal. What is my K then? $8.50. And once again, are these two equal to each other? Yes. So this is an indicator that I have a proportional situation. My equation is, in order to get the cost of each t-shirt, I must multiply $8.50 by every single t-shirt. So this is the equation for this scenario, and it's proportional. Now what we're going to do is take a look at a graph. So when I'm trying to find the constant rate of change in a graph, there's one thing that I like to ask myself: is this graph in the shape of a line? And it is. And usually when your graph is going in that shape of a linear situation, there is a direct relationship between your x variable, your number of jam jars in this case, and the total number of cups of sugar that are needed. One thing I like y'all to do, since I know in order to find the constant rate of change, I need to take my change in y over change in x, is I like to get two ordered pairs from the graph. So I'm going to go ahead and take the first ordered pair, which is 2, 1, all right, and then 4, 2. And you know what? Let me change my colors on this for a specific reason, okay? So, again, I have ordered pair 2, 1, ordered pair 4, 2. They were so nice to give me that. Label your domain values as x, as we've been doing with our functions, okay? And again, how do I find the constant rate of change? Well, change in y over change in x. So I'm going to start, and I'm going to subtract 2 minus 1. There's my y's. Remember, they must correspond. And 4 minus 2. Doesn't matter if I were to gone 1 minus 2 and 2 minus 4. Just make a decision and go in the same order, okay? So when I subtract this, I get 1 over 2. So my constant rate of change here has to be a half. So it's almost as if I need, right, half a cup of sugar for every 1 jam jar. So that's what it looks like here. I need half a cup of sugar if I'm going to make, right, 1 jar of jam. Lots of sugar and yummy, yummy. All right? So there's my constant rate of change. Now I need to see if this is a proportional situation. All right? So let me take a few of my ordered pairs. So I have 2, 1, I have 4, 2, and I have 6 and 3. And once again, it's y, it's your y divided by your x. So I'm going to take 1 and divide that by 2. Well, that's a half, and that's in simplified form. That's also equal to 0.50. I'm going to take 2 and divide that by 4, and if I simplify that, that's also equal to 1/2 or 0.50. Then I'm going to take my 3 and divide that by 6, and when I do that, that also gives me a half, which is equal to 0.50. So I can see, are my ratios giving me the same constant of proportionality? I'm going to say yes. So ratios are equal. That means I'm definitely dealing with a proportional situation, but also you can see that the constant of proportionality and the constant rate of change are equal. Another thing I want to point your attention to is, am I going to have any sugar if I have 0 jams to make? No, right? 0 jams, jam jars, right? 0 sugar. So when you see that your graph has the ordered pair of 0, 0, this is a nice indicator as well that you're going to have a proportional situation. Let's look at one more example. So once again, I'm looking at X, the number of tickets, and Y, the cost. I can see here, though, that my number, that I do have definitely a constant rate of change, because I see that my shape of my graph is going in a line, in a linear situation. So let's go pick 2 ordered pairs and find that constant rate of change, right? By doing change in y divided by change in x. So I'm going to go pick this point right here, 224. Or, once again, let me use my color blue. 2 tickets cost $24. And let me go ahead and find 6 tickets cost $32. 6 tickets are costing $32. Label your x coordinates, please, and your y coordinates. This just kind of keeps things in order when you're finding your constant rate of change. So again, change in y, 32 minus 24. Your y's, take the change in the y's, and then you're going to get 6 minus 2 in the bottom, right? So remember that you're going in the same order. Let's go figure that out. So 32 minus 24 is going to equal 8. 6 minus 2 is equal to 4. So your constant rate of change is equal to 2. All right? So somewhere there it seems like they're charging you $2 for something, right? $2 for the number of tickets. All right. So let's go see if this is a proportional situation. Well, let me just take the 2 points that I already took up there. 224, so again, change in y. So I'm going to take 24 divided by 2, and that's going to equal 12. Let me take the next ordered pair, 6 and 32. 6 tickets cost $32. So once again, keeping my colors in check, I'm going to take $32 divided by 6 tickets. And when I do 32 divided by 6, that's going to give me not a pretty number, but 5.3 repeating. So again, are my ratios giving me the same answer? I have to say there's not a constant of proportionality because these two ratios are not equal. So ratios are not equal. So here I have a CROC, right? I do have a constant, but I have no constant of proportionality, so therefore not proportional. Constant rate of change I have, but it's not proportional, okay? So as I think about the equation here, I know my constant rate of change, so let's go ahead and just go look at the number of tickets that are being charged. So I can see, and I'm just going to set this up, my first point is 2, and 2 tickets cost $24. I have a constant rate of change of 2, so let me see what happens if I do 2 times 2. Well, that gives me 4. How did I get 20? let's go check the next point of 6 tickets, $32. Well, if I multiply 2 times 6, that's 12. What else are they doing to get to 32? I got 4. What did they do to get to 24? Looks like they're adding 20. Let me check. 12, plus 20. Oh, seems like I got my equation. Y equals $2 for every ticket, plus they're adding $20 in order to get the total cost. And if I look at my intervals at 0 tickets, 0, that's 4, 8, 12, 16, yep. At 0 tickets, it starts at 20. So there must be a fee. Notice your graph did not start at the origin. Your graph started at 0.20, indicating that we do not have a proportional situation, okay? All right, your opportunity, I'm going to give you a situation, and once again, you're going to have to find the constant rate of change, right? Y minus y over x minus x. And then you're going to have to see whether this relationship is proportional. Does it have a constant of proportionality? And circle yes or no, proportional or not, and see if you can write the equation from the situation. All right, make sure that you're in class tomorrow so that we can discuss this important concept. Have a great day.